Good day to all and welcome to this online course. In this first module, we will conduct an overview of the principles of breaking electrical circuits, produced by Zensel Automation in collaboration with Hydro-Quebec. Goals of this module. At the end of this module, the participant will be able to describe the principles of breaking a circuit and relate them to the speed of circuit breakers. Lesson 1. Basic Principles of Electrical Circuit Breaking. Why break an electrical circuit? What happens during a high-voltage break? What are the means by which the arc does not re-establish itself? Why break an electrical circuit? Breaking an electrical distribution or transport network permits the isolation of part of the network from the rest of it. A high-voltage circuit is mainly opened in one of the three following cases. The first case, for maintenance needs or in case of a new installation. The second case, when protection devices detect when thresholds or limits are exceeded, for example, during an overload in the network, generally caused by excessive consumption by the customers, a threshold has been exceeded, thus the circuit is broken. Moreover, operating limits are set for electrical apparatus, to avoid premature wear. The third case is that of electrical short circuits, either transient or permanent. Transient short circuits are generally due to severe storms, lightning strikes, tree branches, or animals. However, permanent short circuits trigger a definitive break that will generally require action by maintenance personnel. What happens during a high-voltage break? In the high-voltage field, separating the contacts is not enough to break the current instantly. When the contacts separate, the current continues to flow and a temporary electric arc forms between the moving and fixed contacts. To understand the damage caused by electric arcs, let's review some of its characteristics. Its temperature may sometimes exceed 20,000 degrees Celsius. Its duration depends on the voltage level, the value of the current to interrupt, as well as the insulating medium in which it occurs. The electric arc ionizes the medium in which it flows. Ionization changes a non-conducting medium into a conducting one. The technological challenge facing us is to retransform this conducting medium back into an insulating one, which means non-conducting. The speed of this transformation depends on the thermal and electrical properties of the insulating medium. Let's see the risks and dangers created by the electrical arc. The electrical arc degrades the mechanical integrity of the main and auxiliary contacts. The electrical arc creates dangerous chemical changes, which can produce explosive, toxic, corrosive gases, as well as gases resulting from the decomposition of SF6, for example. What are the means used by which the arc is extinguished and does not re-establish itself? To extinguish the arcing current must become zero and stay at zero. By varying the opening speed and the distance between contacts, the power and duration of the electric arc are greatly affected. Sufficient contact spacing for certain insulating media helps a lot in cooling and extinguishing the arc. What does regenerating the insulating medium mean? It's the capacity of the insulating medium to regain its original electrical properties once the arc is extinguished. How fast the arc is extinguished greatly depends on how fast the insulating medium regenerates itself. This is the deionization speed of the insulating medium. What are the most popular insulating media? The foremost used arc extinction media in the North American high-voltage field and their regenerative properties are listed in the following table. This table is divided into three columns. The first column lists the various types of insulating media. The second column specifies the regeneration time of the medium used, and the last column lists the disadvantages of each medium. Note that this table uses ambient air as a reference. If the insulating medium is ambient air, the regeneration time is very slow. If it is compressed air, the regeneration time is good. However, braking operations are very noisy. One must also consider the bulky air compression and dehumidification systems. When the insulating medium is oil, its regeneration time is better than that of air. The problem with oil as an insulator is that it decomposes. This means frequent maintenance and high costs. If the insulating medium is a vacuum, there is no regeneration time because in theory the arc never occurs. The problem with vacuum chambers is that it is difficult to measure a vacuum and to follow its decay. With SF6 gas as an insulating medium, we have a very good regeneration time. The disadvantage of this medium is that it generates greenhouse gases, polluting our atmosphere. One must also note that SF6 gas may be combined with other gases, such as nitrogen N2 or even CF4 gas. These mixtures prevent the liquefying of the medium in low winter temperatures. Now to the cooling of the insulating medium and the contacts and circuit breakers. One way to prevent the reestablishment of the arc is to cool the insulating medium as well as the contacts. To understand these phenomena, let's analyze the various braking technologies used in high-voltage circuit breakers, and the techniques used to cool their medium and their contacts. But first, what is a circuit breaker and what does it do? A circuit breaker is an electromechanical apparatus that interrupts currents under normal or abnormal operating conditions. Under normal operating conditions, it disconnects the loads present on the network. Under abnormal operating conditions, it operates when electrical faults exist. As mentioned previously, there are various insulating media. This photo shows an air blast circuit breaker. This type of circuit breaker has one or more hollow contacts connected to a compressed air tank. When an open command is received, the contacts separate, and the arc is extinguished by a high-pressure blast of air between 20 and 35 bars. The insulating medium and the contacts are thus cooled. There are two types of circuit breakers that use oil: bulk oil circuit breakers and minimum oil breakers. In bulk oil circuit breakers, the contacts are immersed in an oil bath. During an electric arc, a ball of hydrogen is formed which extinguishes the arc by the oil. In minimum oil breakers, the oil is directly injected into the arc. In the case of circuit breakers using a vacuum in the braking chamber, the principle is to maintain a very low pressure on the order of 10 to the power of -8 pascals. In this type of medium, the arc is eliminated by the contact particles which force it to follow a very specific path until it is extinguished. The principle behind SF6 gas circuit breakers is when the moving contacts are in motion, the compressed gas is directed toward the arc to extinguish and cool it. The properties of this gas cause it to regenerate quickly, and it also cools the contacts very quickly. Question for Lesson 1. During a hard phase to earth fault, the break is performed for the following reason: 1. Maintenance. 2. Exceeding of thresholds. 3. Transient short circuit. Or 4. Permanent short circuit. The correct answer is 4. Permanent short circuit.